We talked about the physical meaning of the nodal points in optical definition of the nodal points. Now let's talk about what is the nodal point, how we can calculate nodal points. So, as I mentioned before, the nodal points are the points that when the rays is passing through those 2 points, the angle relative to the optical axis for incident beam and exit beam is the same. So that's the definition of the nodal points. We have a lens here, refractive index n1, n2 for the glass, and n3 outside of the lens. As I mentioned before, when n1 is equal to n3, the nodal points coincide with the principal points. So for the front principal points, we have front nodal points, and for the back principal points, we have back nodal points. And the same calculation for finding the principal points, we can do the same to find the nodal points. So, but when you have the same material, the 2 points coincide with each other. Now, let's say in another scenario that when you have two refractive indices on both sides that are different, n1 and n3. So in this case, we have a shift, and that shift can be calculated by this equation. And we usually use delta n. Delta capital N is equal to n3 minus n1 times effective focal length. So the shift in the nodal points from the principal points can be calculated by this equation. And for both sides, we will have the same amount of shift. So when you look at this equation, even for immersed optical system that you have the same refractive indices on both sides, let's say 1.33 for one side, 1.33 for the other side, the delta n is going to be 0. So when the delta n is 0, it means that the principal points are on top of the nodal points. So even for immersed optical system, we have to have one side refractive index different than the other side in order to have nodal points at a different location other than the principal points. And when your effective focal length is larger, then the effect of the shift is also larger. So delta n is proportional to effective focal length.